Hello everyone. Welcome to today's Fact of the Day. Today we'll take a look at what it is and what it could mean if proven true. So, what is it? Dark energy. When the Big Bang Theory, the actual scientific theory and not the TV show, was initially proposed, theories about what that meant for the life cycle of the universe began to pop up. One, which most scientists believed would be proven true, was that, like with any explosion, the universe must have expanded extraordinarily rapidly immediately following the Big Bang, and then, still following typical explosive behavior, it would eventually slow. This led many to believe in a theory called the Big Crunch. This theory posited a horrific end to the universe. The gravitational forces pulling the universe back together would lead to cataclysmic chaos as planets, stars, and entire galaxies would collide. The universe would turn into a celestial hellscape of apocalyptic pinball. Eventually, this big crunch would lead to the entire universe retracting back to a singularity, much as it was before the Big Bang. However, in 1998, the Hubble telescope turned to study distant supernovae. Remarkably, the observations showed that the theory of a big crunch was most likely wrong. Instead, the evidence showed that space had actually been expanding slower in the past. The expansion was speeding up. The scientists had no idea what was causing it. It didn't seem to make sense to them, so they proposed a new explanation: dark energy. Since then, the idea of dark energy has become central to much of the study of space. Scientists can use it to plot trajectories of faraway locations, and it can help us to better date objects at great distances. Despite the importance dark energy has gained within astronomy, there is still almost nothing we truly know about it. As the name suggests, it's a dark energy, meaning we can't really see it. The only reason we even truly know it exists is due to its undeniable impacts on space. By looking at those impacts, there are only a handful of features we really know about it for sure. It seems to be almost everywhere. In fact, studies have shown that the elusive energy makes up around 68% of the entire composition of the universe. For reference, the matter we see and use make up only 5% of the universe's composition. That's all stars, gas, galaxies, everything. 5%, while dark energy is 68%. We've also been able to deduce that it is repulsive in nature. No, not repulsive like the smell of rotting milk, but opposite of how gravity attracts, dark energy seems to push things away. Insanely, that has led dark energy to do the one thing which no one thought possible: break the speed limit that was set by Einstein and light. It has been recorded that a number of celestial bodies are breaking that speed of light. This is due to the fact that dark energy is expanding the space in between us and those celestial bodies at a rate of nearly twice the speed of light. The breaking of the speed limit has led to the theory that dark energy will lead to quite possibly an even more terrifying end to the universe. The theory, going by the interchangeable names of the Big Freeze and heat death, states that dark energy's repulsive forces will continue to speed up the process. Over the eons, galaxies will grow further and further apart, eventually losing sight of each other. For anyone still alive, the only things you would know existed would be within your own galaxy. It doesn't end there, though. Eventually, that same process will rip apart those galaxies, sending stars off on their own to wander the blackness. Eventually, any and all stars other than the one you orbit directly will disappear from your sky. Then, the solar systems will fall victim, should any stars still exist. Any survivors will be left to float through the icy blackness forever alone. In this scenario, stars and galaxies will eventually burn out completely. There will be no new creation, no new stars. The universe will be left with just black holes. But without matter to absorb, they will eventually fall victim to Stephen Hawking's Hawking radiation. This Hawking radiation bleeds black holes of their particles over time and will eventually be responsible for the deaths of the last objects in the universe. The universe will eventually bleed all of its heat and settle at a temperature just above absolute zero. All thanks to dark energy. Though this is absolutely a terrifying process, the timescale on this is over hundreds of trillions of years. In fact, the last black hole won't burn out for about a Google years. That's a 1 with 100 zeros. As stated before, little is really known about dark energy. There is still everything to learn about it, and perhaps, as our knowledge around it grows, we will learn how to curb its repulsive nature. Or perhaps we'll learn how to harness it ourselves for use here on Earth. Dark energy continues to be a subject of intense scientific research and investigation, as astronomers and physicists strive to unlock the mysteries of this enigmatic force. Thanks for checking this out, everybody. Have a great day. If you like this video, make sure to give it a like and a subscribe.